All right. Welcome to the Q&A session for week 1 of Systems at Scale. Let's give it a couple seconds for our presenters to transition in. Everyone, my name is Michael Chang, and I will be the facilitator for today's session. And it looks like we have all 5 up. For all of our attendees, we will be answering your questions as they trickle in. The first question will be for Marilia. So Marilia, how do I know how many SLOs I should define for my service?
Hi, Michael. Thanks for having me. Thanks for the question as well. Usually the SLOs you have, instead of focusing on the functionalities of your system or the dependencies of your system, the best way to do is to actually focus on the user. As I explained, there is one thing that we call the critical user journey. Describe the journeys that your user goes when using your system and prioritize that. So a very good thing to do is to start with the most critical one, because that will have the most impact on your system. That if users are not able to use that functionality, you can actually fix right away and provide a very high impact on the reliability side as a SLO for your system.
Thank you very much, Marilia. Looks like there was a question for William. If I wanted to use dynamic concurrency limiters, like how can I use them?
Yeah, thank you for the question, Michael. We actually wrote a blog post about this at Netflix a little bit ago and open sourced the code on GitHub for the dynamic concurrency limiters. So if you just search for Netflix concurrency limiters, you'll pretty much find the blog post and the code right there at the top. I talked about service-to-service interactions today, but there's also examples in there of how to use it for thread pools and executors and all sorts of other approaches as well, where sort of these invisible queues that David had talked about spring up and might get the better of you without some type of a limit in place.
Got it. Thank you very much, William. Looks like we have a question for Kiryong and Lin. So other than measuring the servable load of a service, where do you use service level load testing?
I think I can cover this question. Actually, this is really excellent questions. Since load testing provide very deep understanding about service at high load, we actually leverages data in various places beyond capacity measurement, such as regression detection, identifying bounding metric, and setting the target utilization and overall testing. For example, we can run load testing for the RC version before pushing this binary to the production and potentially block this new binary if there is a significant regression in the maximum servable load.
Thank you, Kiryong. And I think we have a question for David. So does Amazon use circuit breakers for helping clients back off services when they're overloaded?
Yeah, actually we do, but first of all, I think I should probably spend a second to define at least what a circuit breaker means to me. A circuit breaker I think of as where the client, instead of even making a request, it may notice that the server is overloaded or think that the server is overloaded, and it'll just fail the request instead of making it to the server. So it never even attempts to send the request at all. And so at Amazon, we like to think of kind of protecting from the inside out. So the server itself has the best view of whether it's overloaded, which requests are more likely to succeed or fail, or which ones are more important or less important. Whereas the clients are sort of guessing at this. And so we like to have that precision and accuracy on the server itself. Now, of course, if it can't reject an infinite amount of requests per second, it does need some help from the client. And that's where we get into that kind of circuit breaker layer. But where circuit breaker kind of go wrong if not carefully implemented is, let's say there's a service that has, say, 100 databases behind it. So it's a client talking to a service which has like 100 databases behind it. So if there were a problem with just one of those databases, that might show up to the client as, oh, there are errors sometimes, talking to the server, I should probably kick in the circuit breaker. But what that would do is turn a single database outage or impact into a service-wide impact, because the clients would be failing requests instead of attempting to call. So when we do use circuit breakers, we're very intentional about how we making sure that the circuit breaker is kind of aligned with like an actual failure mode and prioritization.
I see. Thank you, David. There's another question for you about your session. This is about asking about a term that you used. What is the meaning of wasting work in a system? And the clarification is obviously that the server is still trying to process the request.
Right. Yeah, it's a good point. I mean, it's not like this. Like the CPU is doing something. It's not like mining Bitcoin or something. It's like actually, trying to work on the request. So that doesn't seem wasteful. But on the other hand, so if you've ever like visited a web page and it's kind of slow to load, so you hit refresh. Well, the thing is, nothing tells the web server typically that you've hit refresh, and so the web server will keep working on your original request at the same time as it is working on your next request from the refresh. So if the server is continuing to work on something that the client no longer is going to get the response for, I consider that a waste. And also it's a waste if that's the part after the timeout, and even the part during the timeout. If a server works on a request that eventually times out, meaning that the client doesn't even get the response, then that was a waste. And like the last thing that a server should be doing when overloaded is wasting work. It should be making sure that everything it does is successful. And so this is actually one thing I was kind of talking about, some Lambda programming models. Like one thing in Lambda is when you configure a function in Lambda, you can actually configure a maximum runtime. Whereas like typically a server will just keep running until the code stops. There aren't generally thread interrupts or things like that. With Lambda, you actually configure a maximum runtime for your function, and if you kind of collaborate with the client and have a similar timeout between the client and the Lambda function, Lambda will actually stop your function after that timeout, and then that avoids wasting further work.
Thank you, David. While we're on the topic of Lambda, there was an audience member that was curious. Does Lambda Sync actually use an application load balancer under the hood, or was that just an example for this scenario?
Oh, well, just a caveat, of course, is we're always changing architectures, evolving things at AWS. So to take this as a sort of point in time, but yes, we do use application load balancers. We use network load balancers. We have systems in between each other within Lambda that talk without load balancers as well. So we use a mix, and that mix includes application load balancer.
Thank you. All right. William, there's a few questions for you. One of them is just one moment. Well, let's see. Could you elaborate on what signals you use in the PIC2 for load balancing?
Yeah, absolutely. It is very simple. It's essentially just looking at the number of outstanding requests from a client perspective to each of these downstream hosts that it can send requests to. And that's really just a counter. It goes up one when a request is sent, and it comes down one when that request either returns or fails. And so in the PIC2, it really is just going like, hey, there's 10 servers I'm talking to, let's say. I just pick 2 random numbers out of that group and then look at who has the lowest counter. And that's the algorithm's all about 5 lines of code log. It's very simple and easy.
I think there's a very, very similar question for David. It's beyond sharded queues. Do you use any other techniques for tenant fairness?
Beyond sharded queues, yeah. So there are tons of layers of kind of multi-tenancy and fairness. I'm not really going to be able to do them all justice here. I actually wrote a pretty long article about this in the Amazon Builders Library called Fairness in Multi-Tenant Systems. So take a look at that. But in short, yeah, we use rate limiting, like a per client rate limiting. I kind of alluded to that we do the shuffle sharding to kind of just isolate customers. But if there is a shard, we still need to be able, like that is hot, we still need to migrate other customers off of that hot shard. And so that uses like health checks and and things like that to move customers between shards. Distant hashing with failover. Yeah, there's just many techniques around fairness that all involve some kind of rate limiting or just load measurement and routing around overload.
Right.
Oh, I guess one thing, the most important thing is just is actually the kind of long-term forecasting. Like, you know, every say Lambda customer has at any point in time has a quota that of how much capacity that they've asked for that they can use. And of course, people ask for more capacity, and we kind of scale things up behind the scenes to make sure there's capacity for them, and then we kind of grant those, you know, increase the quotas for people. And so that's actually the most important part of that, is that capacity management. It's so that we don't so that nobody runs out of their capacity, and make sure that we give visibility to customers about how close they are to their limits, so that they can request more in advance and that type of thing.
Got it. Marilia, there's a question for you. So as we're all supporting some very, very large and complex systems, how do I define my SLOs if my service happens to depend on multiple other services?
That's a very common question, and especially at this stage where most of the system are system at scale that relies on other functionalities. The approach, instead of thinking about all the dependencies and the risk and their own SLOs and then calculating our SLO on top of that, it's actually better to do the top down. You first focus on your single SLO that you want to create and track. And then after you actually measure your SLO for a while, you can see what are the risks that the dependencies are actually causing to your SLO. Most system has a very conservative SLOs, so you should actually calculate on top of that. That may be too conservative for you because, you know, so many dependencies. So the best approach is actually create your own SLO, track that, and once you identify your real SLO, the availability that you have measured, consider which risks the dependencies are actually causing to that SLO. And then from there, you can work on how to mitigate the risks that each dependency causes to the system.
Got it. We also have a question for Lynn and Kiryong. Quite a few people are interested in this. And it's about how you're doing load tests in production. How do you prevent any problems with availability to real users? I know you guys talked about this slightly in your talk, but if you can go deeper into it, that would be great.
Yeah, I can try to cover that question. So what we do is that we actually monitor a bunch of health metrics for our major systems. For example, if this is for Facebook load testing, then we monitor how well the web tier is doing, the front end, and then like major systems such as like feed, ads, and other systems. So we use a similar metrics or health signals as a service owner uses, like the arrows or latency for their client requests. Also, I think the service owners usually monitor things as their resource consumption because they know that like which is more linear, and we kind of have a good understanding of when that will be the bottleneck. So that's give us better understanding of how these systems are all working. So we can hopefully stop the test or start to reduce the load before we actually error out. Yeah, so we got lots of coverage in that sense. Also, another benefit we've seen is like we use similar metrics or like alerting as service owners, so that this also covers any dynamic change they have. Yeah, but usually we are more conservative because we don't want to actually cause issues for the services. Yeah.
I see. Well, similar question around using live traffic for load testing. So Kiryong and Lynn, how do you guys achieve reproducibility if you're using live traffic?
Let me try to cover this one. This is actually a very insightful question. I think, in fact, this is one of the challenges we've been having when using live traffic. So while live traffic actually represents the production workload, it can be difficult to work with because we don't have full control on the testing environment. So in other words, getting stable result across multiple tests is important, but challenging. So we actually implemented multiple approaches to get more stable and consistent test result. One approach is a spike tolerant mechanism. We want to avoid situations where our load testing is accidentally stopped because of external factors like network kickoff or transient errors. So spike-tolerant logic helps tolerating a temporary metric spike by verifying that metric is consistently spiked at a certain node. We actually shared more mechanisms to produce high-quality data at the blog post. So please take a look at those.
Thank you, Kiryong. Going back to David, I guess we have some more Lambda questions. How does Lambda know a client timed out? And as when we talk about this, like who is the client?
Got it. Yeah. So this is actually this is sort of the challenge is it doesn't. Lambda doesn't know if the client timed out. So when you configure your Lambda function, you can actually configure it to have a maximum runtime, and you kind of, if you know who your clients are, the client would be whoever is invoking the Lambda function. I mean, Lambda is used for web service APIs, for example. And so if you know that the client of a web service API has a timeout of 5 seconds, then you can make the API, the Lambda function itself, have a timeout of 5 seconds. But actually, one technique that we use throughout Amazon is actually the client just tells the server what its timeout is going to be on each request. You can just send some HTTP header that says, by the way, I'm going to time out after 3 seconds. And then the server can start a stopwatch when it gets the request and say after 3 seconds, maybe sometimes we'll scatter that logic throughout our code to say, hey, I'm about to do something that's going to take a long time. I should check the clock to make sure that it hasn't been like too long for this request already. And if so, I know that the client will have timed out. I think William was talking about techniques like this as well.
In that case, why don't we go to William? There was a question about the load balancer. In an adaptive load balancer world, how does it detect and adapt to slow requests? Or I guess another way we can generalize it is, how does adaptive rate limiting behave in a world where a service might have more spiky properties, or potentially a world where it might have lower queries per second?
Yeah, it's a great question. So the assumption I know a lot of folks make is that there needs to be a very uniform distribution of request sizes or arrival rates or these types of things. And while that certainly does make sort of the algorithm and the discovery smoother and better, even still sort of spiky workloads or uneven distribution of requests is possible, because it's essentially using a TCP style algorithm to see what is the longest that a request should take through the system. And so as long as those things are still showing up at certain points and the rate of growth of how long they take to process is not increasing, these systems will adapt and sort of just look at these types of requests to make their decisions. And so there are some weirdness that you can get around head requests and other things where if you have a service with, let's say 20 different requests and 5% of them are always really slow just because of the type of requests they are, those may then be the ones that always get hedged if you have like this 95th percentile target for a hedge request. And so in those cases, there is additional configuration available to say per API endpoint specify what keeping track of the math for like the head requests and other adaptive things can happen on a per endpoint basis rather than for the whole service. And so some of those mechanisms then allow for folks who do have services with, let's say, a multiple distribution request patterns to sort of segment their traffic with the configuration of these tools, so that you don't end up with, let's say the same 5% always being hedged and nothing else having that done.
I see. Thank you, William. We have quite a couple going back to the load testing side. So Kiryong or Lynn, can you elaborate on how the actuators interact with traffic or network control? So I think the example that was provided was load testing 5 out of 1,000. What is the directive that the traffic control system receives?
I see. This goes a little bit detail. I think detailed mechanism varies by the traffic routing system we interact with. But in high level, most of the traffic routing system has load balancing mechanism, where we can input the probability that a particular host will be selected for a certain request, or tweak a metric for load balancing. So in high level, actuator asks the traffic routing system to increase probability of sending traffic to a particular host the load testing is running on. For example, all the hosts have weight 1, but then we ask load traffic routing system to increase this probability from 1 to a higher number, so that load balancing system will select this host more for sending the traffic. For a similar example, another example is we may be able to change the weight at a particular node in consistent hashing, so that this host related to this node gets more traffic for load testing.
I see, thank you. Similar and a related question. It looks like a viewer is curious about the different use cases for a load controller versus the actuator. What is the separation of concerns, and how do their use cases differ from one another?
I can also cover this one. So if I rephrase the question, it's about seeing the distance between the load controller and actuator, right? So load controller doesn't actually change the load. It actually calculates the amount of load we need to run at a given moment at a given host. So it has abstract value starting from 1 to higher number. And then actuator actually materializes this number, abstract load number, into the traffic routing system. So a good example is if we like to simulate overload testing, then we just need to implement a new load pattern by updating load controller. And all the services that already has actuator will just take the input from this new load controller and do the simulation, well, change the load in a way that load controller asks load actuator to do. I hope that makes sense.
I think so. Thank you very much, Graham. All right, Marilia, going back to you. There's a follow-up question on SLOs. Are there common user statistics that allow us to more accurately determine the services SLOs? And if there are, what techniques or challenges do you find in gathering them?
Yeah, so usually there is not kind of specific user statistics, but the way to have better, more accurate SLOs is the closer you are to the user to measure the user actions, the more accurate that will be. For example, imagine that you have a Facebook app on your phone, right? If you can actually calculate the interactions on the phone, it's actually better than you actually calculate when it gets to the load balancer that you have on your system. Unfortunately, that's one of the challenges. It's very hard to have most of that calculation done on the device, on the user devices, and sent to you. So it's very common to have people setting up the SLOs, for example, based on the user requests that are measured on the load balancer. And that's how important it is to specify your SLI, the service level indicator. What is actually going to be the indicator that you're going to use in your calculations? So most of the time, people use the HTTP requests, which are a very good and generic, broad assessment of your service capability and availability to the user, and kind of very easy to calculate depending on the 200s, 500s on the status that they have at the servers. But you need to be careful on calculating just on the server side, that making sure that actually that's a real representation of the user experience that they're having on their devices as well.
Got it. Thank you, Marilia. Going back to David, I think there's a question about rejecting excess traffic right away. So the question is, would it be better if a service queued up the request instead of just rejecting the request right away?
In terms of queuing or quick rejection, we tend to go for the quick rejection because queues build up really quickly. There's this thing called Little's law that describes the amount of concurrency in a system. on average to be equal to the arrival rate of requests times the latency of processing the request. So the concurrency in a system is something that we don't always think about as being a kind of a scale limit or anything, but it takes resources. A request that's just sitting there still takes memory, file descriptors, whatever. And so requests can really pile up quickly if latency goes up. Like if latency doubles, then we need double the average latency doubles, then we need to average the concurrency support in a system. So the challenge also is that queuing can also be typically handled in sort of a FIFO, first in, first out way, as I kind of described in the talk. And so if we are queuing requests, we're putting more work on the server, and that's the server can have maybe more be pretty constrained at the time and not want to just pile up work. And then furthermore, in processing those requests, if it's a first in, first out queue, each request is being processed after a delay. It's like if you're running a race and you're already starting from like trying to run a 100-meter race and you're starting 100 meters back, it's going to be harder to meet that, whatever 10-second time or something you're trying to hit. So yeah, it's just we tend to do quick rejection and have the client do retries, because actually if the client is going to retry a request, at the end of the day, to that client, that looks like latency, not errors. If they retry a request and it succeeds the next time, that looks just like latency, which looks the same as if the server had queued the request. So there are some exceptions to this where we do queue, but most of the time, like if it's an expensive, like say Handshake or something like that, then it might be actually cheaper for a little while to queue just in case we actually can get to that request. But during an overload, we don't want to just flip into some other scaling mode and have a bunch of concurrency that starts to cause problems in the system.
Got it. That makes sense. Thank you. William, there's a question about how do we know that the discover concurrency limits are actually correct?
Yeah, the reality is you don't necessarily. Maybe the way I'd answer that is that there is no correct value. We've sort of created that as an illusion for ourselves in the way that we built services historically. Discovering what is an acceptable value to set when we traditionally set like a limit at 10 or 20 requests at a time coming into a system. And so the way to really think of a dynamic concurrency limit is more that it is the discoverable amount of work that can be done on that particular machine at that particular point in time for the type of work being done. And I would actually argue that is the correct value. Obviously, there can be bugs in there, and there's a ton of metrics and other things that get published out of the operational side of these tools that developers can use for those situations. But generally, I've found when something looks to be out of the ordinary, we've typically discovered some reason for it once we've dug in and actually looked at it. The algorithm, detected it in an area where we probably wouldn't have as a person.
Back to David. David, I know you've described an assortment of techniques, but hopefully you can wrap this all up with this question. Question is, in Lambda, how do you handle a task that requires more than the available resource in the Lambda environment during the runtime?
So in Lambda, I was kind of, I guess maybe I was covering this maybe in a different question, but I think when it comes with Lambda, like I said, at any point in time, any customer has a certain amount of quota of compute resources that they can use at any point in time, and they can always ask for more. And we'll just make sure that we've pre-provisioned resources behind the scenes to account for that, so that it's there when it needs to be. And so it's these quotas that are in any multi-tenant system that need to be there, and then but when it comes to managing these quotas, customers need to be able to do so easily. They need to have visibility into how close they are to those quotas, and we can also like I said, it's a really long topic. I don't want to keep going here. So search for the Amazon Builders Library and look for the Fairness in Multi-Tenant Systems article to get the really long form answer on this one. But at the end of the day, capacity planning and quota enforcement. And then be as flexible as possible within those quotas. So that's the real magic trick.
Thank you. And I just want to remind all the viewers or any of those that may have joined, we are taking live questions right now. There's a question for Kiryong and Lin. How does running load tests in production accommodate for sudden bursts of real production requests? So if we have a load test going on and suddenly a surge of production load comes in, how do we make sure that all this traffic gets served?
Let me try to cover that question. I think the first part we are hoping for is that our traffic routing system can distribute this load to all the regions, not just the region or the host we are testing, so that the region doesn't get hit as much. The second part is, okay, so the region is getting more traffic. What do we do? We've actually seen this in the past. I think there was a soccer game, and at the time, one team gold, we saw a burst of traffic from that particular area. And that was so obvious, you can actually see them from the graph. And it happened to hit a region we were actually testing. At that time, I think we do hope that our systems are also can do overload protection for themselves, other things. But in the load testing itself, we try to detect these signals as fast as we can, in terms of seconds, hopefully. And then we saw the matrix health signal start to be really bad, and then we immediately reduce the load to that region. Hopefully, everything can be recovered within seconds or minutes. Yeah, we can't really prevent traffic hitting us, and then the best way we can do is to reduce load at that time, unfortunately. Yeah.
Got it. And then David, back to you. I think there is a question about retries and system reliability. So there's definitely a camp that views that retries make systems more reliable. Are you suggesting that retries are potentially bad?
It's one of these things that a few are great, but a lot are catastrophic in a way, to be a little bit of hyperbole there. But yeah, so certainly we do see that typically our customers prefer a slight increase in latency every once in a while. So an increase in outlier latency over a few errors once in a while. Maybe just it's less noticeable sometimes for customers. It depends on the client and the customer, but that can be the case. And the problem is if there are a lot of retries, that's what really amplifies load during an overload, especially if there are a lot of timeouts. They can lead to more traffic, what can lead to more timeouts, right, and more load. So this is one of those. We talked about circuit breakers earlier, but this is a circuit breaker that is pretty non-controversial that we implement in all the AWS SDKs, which says whenever any client using the SDK is doing retries, if it's seeing errors from the server, it doesn't do retries anymore. It uses a token bucket to kind of automatically tune how many retries it'll do. So if it's getting errors from the server, it doesn't retry anymore. It still it does the initial attempt, so it's not really it's not a particularly dangerous circuit breaker. It just stops retrying if the retries aren't working. And it'll eventually start retrying again once the server is back and responding normally. So I'd say we generally are but the problem is, okay, so this is in the AWS SDK, but what else is a retry? Anybody can write a loop that tries multiple times. Well, if that's just a loop that's written in code without this kind of circuit breaking logic, that's dangerous. We're very careful about to avoid dangerous retry logic that can amplify load. Yeah.
Got it. Thank you, David. I think we're pretty much wrapping up this week's Q&A session. Thank you very much to all of our presenters, and thank you all of the audience for joining us for week 1 of Systems at Scale. This week it was focused on reliability. For those that are looking forward to it, on June 16, 2021, we will have week 2, and that will be focused on cluster management, capacity, and provisioning. So hope to see most of you there. Thank you very much, everyone.
Bye-bye.